Hi. So we'll continue with this course on integrals, and the question that we are now going to look at is a question that is very similar to a JEE 2002 advanced question. So this is the problem. We have to evaluate this integral plus 3x power 8 plus 6 whole power 1 by 8 dx, right? So uh, this question calls for doing a correct substitution. So for example, if I try to do the substitution right now here, 2x power 16 plus 3x power 8 plus 6 is equal to t, then get 32x power 15 plus 24x power 7 dx as dt. But that is not the correct substitution here, because clearly, like, it doesn't work, it doesn't match any of the other factors, right? So what we will do is try to take some term common from either of the two factors and hope that if you insert it in the other factor, some power of x, if you put it in the other factor, it will become something else that is solvable by the method of substitution. So you can try anything. You can try taking x power, like, actually you cannot take anything common from here, right? No x can be taken common from here without making an x power minus something. So that is not ideal. So something can be taken common from here though. Like if I take x common from here, I'll be left with x power 23 plus x power 15 plus x power 7. And if I put this x in the second factor, right? When it goes inside the bracket, it will become x power 8 there, right? Because only if you write 2x power 24 plus 3x power 16 plus 6x power 8 whole power 1 by 8, from here you could have taken x power 8 common, which will come out and become an x, right? So what we do here is basically take out an x from here and put it inside this factor, and this becomes this, right? So my integral looks like this now: x power 23 plus x power 15 plus x power 7 multiplied by 2x power 24 plus 3x power 16 plus 6x power 8 whole power 1 by 8 dx. Now what is nice about this is that when you differentiate this, when you take this as t and differentiate it, dt will become 48x power 23 plus, notice that 3 into 16 is also 48 and 6 into 8 is also 48. 2 into 24 was also 48. So you'll get 48x power 15 plus 48x power 7 whole dx. So therefore dt is equal to 48 times x power 23 plus x power 15 plus x power 7 dx, right? So this thing now is equal to dt by 48, which is very useful because we have this and this, which is the same matching thing here. So we can write this integral now as t power 1 by 8 and dt by 48, which is easily integrable. It will be 1 by 48 t power 9 by 8 by 9 by 8. So 8 by 9, which is basically going to be 6. So 1 by 54 t power 9 by 8. And you put back your t, you get the answer. T was equal to this quantity, right? So the idea here is that when direct substitution doesn't work, try to manipulate the expressions in such a way that maybe a slightly different version of the same expression has a good substitution that is working. The reason this substitution worked was, once you make it x power 24, x power 16, x power 8, 2 into 24 is 48, 3 into 16 is 48, and 6 into 8 is 48. And you get the correct set of powers, 23, 15, and 7 after differentiation, right? So I hope you understand this trick, and this has been asked in IIT and it might come again. Like, it is possible that you can get a question like this again. So be prepared. The next one that we look at is this one, problem number 13, which is integral of x power 9 by 4x square plus 1 whole power 6 dx, right? Okay. So We have x power 9 there, and we have 4x squared plus 1 whole power 6. Now, obviously, direct substitution doesn't work because you should have an x on top, right? If it was an x on top, direct substitution would have worked, right? So what we will do is we'll divide by some powers of x up and down. And if we divide, like if I take x square outside here, right? So x square outside makes it x power 12 when it comes outside the power 6. And this becomes 4 plus 1 by x square whole power 6, right? And on top is x power 9 dx, correct? So this becomes x power minus 3 dx by 4 plus x power minus 2 whole power 6. And now you notice that 4 plus x power minus 2 is equal to t will work fine, because you'll get minus 2 x power minus 3 dx is equal to dt, and therefore x power minus 3 dx is equal to minus dt by 2. You can apply this here and it becomes minus dt by 2 by t power 6. So again, the technique here, after this it is solvable, so I'll not go into the details here. Again, the technique here was taking an appropriate power common and trying to get the substitution working. So once you take x power 12 out, it becomes 4 plus 1 by x square, and 1 by x square differentiation is in the form of x power minus 3. And that is what we get on top here, right? Let's look at another problem, question number 14. This talks about integral 3 plus root x divided by x plus 2 root x plus 3 whole square, right? Okay, dx, right? Again, the idea is similar to what we have tried so far. You have to think of how to take powers common maybe and get a situation where a substitution will work, right? So here, what we can do is we can take x outside this fraction, and what we will get is x square comes out and it becomes 1 plus 2 by root x plus 3 by x whole square, and x square comes out and it is 3 plus root x dx. So now notice that differentiation of this is 2 into x power 1 by root x. So 1 by root x differentiation will be minus half x power minus 3 by 2 plus 3 into minus 1 by x square whole multiplied by dx would have been your dt if I have called this as t, right? So this, simplifying it a little bit, minus 1 by x root x minus 3 by x square dx, right, is equal to dt, and you get minus dt is equal to 1 by x root x plus 3 by x square dx, right? Okay, and what happens if I divide this x square here? Notice that the numerator becomes 3 by x square plus 1 by x root x dx by 1 plus 2 by root x plus 3 by x whole square. So now see how it has worked out when you took x square common. This is your t and this is your minus dt. Integral is simply minus dt by t square, which will be 1 by t. So that will be the answer. You'll put back your 1 by t and you'll get the answer, right? So I'm just showing you different ways in which this method of substitution works, and hopefully you will apply it in your problems as well. Let's look at a slightly different question. Question number 15 now. This is e power tan x whole multiplied by 3x square plus secant square x multiplied by e power x square plus 2x plus secant square x multiplied by e power x square dx. We have to find this integral. Now we should probably separate it out into two separate integrals, because notice that one of these factors is 3x square e power x square, and there is a 2x e power x square, and the other one has just secant square and stuff, right? Okay, so Yeah. So what we get is e power tan x, e power tan x, uh, we get 3x square plus 2x e power x square plus secant square e power x square plus secant square e power x square. So 2 secant square x e power x square, right? This is the integral right now, correct? Okay, so we have this integral e power tan x multiplied by 3x square plus 2x e power x square dx, plus we have another integral 2 secant square x e power x square dx, right? We have two separate integrals here. Let's try to do this one first. So here, this can only be done by integration by parts. So we will try to do it by integration by parts. We will probably use this as the first function and this as the second function, because this function, we don't know the integral of this. This we possibly can integrate. We have to think about it, but it is possible that we may be able to integrate this. So, okay. I think there is a strong temptation here to take tan x as t here, because sec square x is there in this term. But we will try it nevertheless. Correct. So okay, we try the integral here. So by parts, if you try to do this, you'll write e power tan x as it is, and you'll integrate this 3x square plus 2x e power x square dx, and minus, you'll write e power tan x differentiation will be e power tan x into secant square x into whatever comes as the integral of this 3x square plus 2x e power x square, right? So our only job right now is to try to solve this one. So integral of e power x square multiplied by 3x square plus 2x dx, right? So if you think about it, e power x cube plus x square, right? E power x cube plus e power x square. No, that will not be correct. So what we have here is e power x cube plus e power x square. If I differentiate this, right, what I will get is e power x cube into 3x square differentiation of this, let's just check once. This becomes e power x cube into 3x square plus e power x square into 2x. So we can take e power x square common and we'll get I feel like there is a slight error in this question. Why is there an e power x cube coming? Yeah, no. Per x square plus e power x cube. We have to integrate this, so we can do integration by parts here as well, right? Yeah, we'll write it as e power x square into integral of this, which is x cube plus x square minus e power x square into 2x into x cube plus x square. So this is what is coming here. Yeah, I feel like there is a slight error in the question because right now it feels like this integral is not doable. If this integral was doable, we should have some higher power of x here, because right now it is easy to solve this integral e power x square into 3x square. That is not an issue, but the 2x part is the problem. 2x into e power x square. So we'll probably come back to it. I'll have to confirm whether this is correct or not. So for now, let's just uh, ignore this. We will come back to this question once I have confirmed whether this is possible or not. We'll move on to the next question for now. Just try it yourself also once, and I will also check back with you. And in probably a future video, we'll check if this integral is doable or not. So right now, I'm not so sure here. So let's go ahead for now and let's look at this particular problem. Question number 16, integral of sine of 101x multiplied by sine power 99x dx. So in this particular question, you have again a product of two functions. So you'll probably use integration by parts, but a direct integration by parts might not be so useful because we need to be able to integrate uh, this function somehow. Because if I integrate this function, I will keep getting stuck in a loop. I will get cos, then next step I'll get sine. So I need to integrate this function to come out of the loop. So what I will do is I will split the sine 101x as sine 100x plus x, which is equal to sine 100x cos x plus cos 100x sin x, right? Why is this useful? Because now we can split this integral into two parts. We have sine 100x cos x into sine power 99x plus cos 100x into sine power sin x into sine power 99x is sine power 100x, right? These are the two parts here. Now we can do this one by parts because this we can actually integrate both, but what we'll take is this one as first function and this one as second function. If this whole thing is second function, the integral of that will be, if you put sine as t, your cos x dx will become your dt and it will become t power 99. So integral is t power 100 by 100, which is sine power 100x by 100. So you get sine 100x into sine power 100x by 100 minus differentiation of this will become 100 cos 100x multiplied by sine 100x by 100, which cancels the 100 and becomes minus cos 100x into sine power 100x, which just cancels this term, right? This integration by parts splits in such a way that it cancels the second integral. So the answer to the whole question becomes simply sine 100x multiplied by sine power 100x by 100, right? So that is a nice looking answer that has come from a complicated sort of a question, right? What happened here was we split the sine 101 into 100 plus 1. And once we split, we are performing integration by parts, considering this as the first function, this is the second function. So we are keeping the first function as it is, integrating the second function here, minus integral of the differentiation of the first function as the answer of the second function's integral, right? So it turns out that it cancels the other integral. So this is fairly easy, but you have to be clever about applying integration by parts at the crucial step here, right? Let's look at another one. This is question number 17. And in this one, we first look at the reduction formula concept. So this is In is equal to cot power nx dx. And we have to prove that I naught plus I1 plus 2 times I2 plus I3 plus so on till I8 plus I9 plus I10. We have to basically find the value of this, right? So here 0, 1, 2, and so on are telling you the values of this n constant, right? So you could have I naught would be just integral of 1. So if you think about it, I naught is integral of cot power 0x, which is integral of 1, which is x. I1 would be integral of cot power 1x, which is cot x. So that is actually equal to log sine x, right? Log mod sine x, and so on. Like you get other answers for I2 and so on, right? However, we are not concerned with the actual answers just for a specific I value. What we are concerned is a way to get all the I values regardless of the value of n, right? So if you write In is equal to integral of cot power nx dx as integral of cot power n minus 2x into cot square x, which is equal to cosec square x minus 1 dx, right? This is actually cot square x here. Then what we can say is integral of cot power n minus 2x into cosec square x dx minus integral of cot power n minus 2x dx. This is equal to your In, right? Now, this is easily integrable because this is going to be cot x is equal to t, and this will become dt minus dt. So you will get minus t power n minus 2 integral is minus t power n minus 1 by n minus 1. So it is minus cot x power n minus 1 by n minus 1, and then there is a minus of I n minus 2, and this is equal to your In, right? So what we are getting here is this is the expression for In which connects it to In minus 2, right? So what we'll try to do here is try to put some values of n. So because n cannot be 1 in this expression, n is equal to 1 is not defined in this expression. So what we get is we start off by putting n is equal to 2. So you get I2 is equal to minus cot x by 2 minus 1 1 minus I0. So you get the equation I2 plus I0 is equal to minus cot x. By the way, this expression which connects a higher integral to a lower integral is called the reduction formula, right? So we'll see many more reduction formulas as we discuss more and more questions. So get used to applying integration by parts to reduce an integral from a higher level integral to a lower integral. So right now we have this formula, and by putting n is equal to 2, we got this result, right? And let's see what other results we can get. So we get I2 plus I0 is equal to minus cot x, and then we get n is equal to 3, we get I3 plus I1 is minus cot square x by 2. You can put it in the formula. The formula is this: In plus In minus 2 is equal to minus cot power n minus 1 x by n minus 1, right? I3 plus I1 is this. Then I4 plus I2 will come out as minus cot cube x by 3, and so on. You will even get I2, I10 plus I8, right? I10 plus I8 will be equal to, when you put basically n is equal to 10, you will get minus cot power 9x by 9, right? Therefore, what we get is, uh, if you add up all of these, right? If you add up all of these results, what we get is I2 comes 2 times, I3 will come 2 times, similarly I8 will come 2 times, and you'll get I0 plus I1 plus I10 plus I9 in the previous step. You'll get one term here, I9 plus I7. You'll get I9 here, and actually I9 will be repeated. No, it won't, because the previous term would be I8 plus I6. So I9 and I10 come once, I0 and I1 come once, and every other integral comes 2 times, right? So you get I0 plus I1 plus 2 times I3 plus I4 plus I8, for example, plus I9 plus I10 is coming out to be negative of cot x plus cot square x by 2, and so on till cot power 9x by 9, right? This is your answer for this problem. And this is an application of the concept of reduction formulas, right? Another question let's look at. 1 second. Let me just look at the question number for the previous one. Okay, this was question 17. So we'll look at question number 18 here. And this is integral of x square 1 minus ln x divided by ln power 4x minus x power 4 dx, right? Okay, so we have x square common here, and we have ln x whole power 4 minus x power 4. So what I will do is I will take x power 4 common. So I'll get x square 1 minus ln x divided by x power 4. I get ln x by x whole power 4 minus 1, right? And this is dx here. So now, if you notice, this x square will cancel 1 by x square, and you'll get integral of 1 by x square minus ln x by x square dx by ln x by x whole power 4 minus 1, right? Okay, so let's try the obvious thing. Ln x by x is equal to t. What do we get? Ln x by x is equal to, we get integration of ln x is 1 by x into x minus ln x into differentiation of this x. No, x is 1 by x square dx is equal to dt. So I'm just differentiating this by quotient rule. I get 1 minus ln x by x square dx is equal to dt, right? Now, clearly here you have on top 1 minus ln x by x square multiplied by dx. And what you have on bottom is ln x by x whole power 4 minus 1, right? So the top part easily works out, and it becomes dt by t power 4 minus 1, right? And that is equal to t square minus 1 into t square plus 1 dt. Now you can split it in partial fractions. You can say that this is equal to half into 2, and 2 is equal to t square plus 1 minus t square minus 1 dt by t square plus 1 multiplied by t square minus 1, right? And then you end up with two separate integrals, half of 1 by t square minus 1 dt minus half of 1 by t square plus 1 dt, right? These integrals are easily doable. This is a formula, standard formula, and this is simply tan inverse t. And you can now put back your t as equal to ln x by x to find the final answer, right? So the method here also is similar to the methods that we have done earlier, where we would take some factor common out of the numerator or the denominator in order to make it work, in order to make the differentiation work, right? Okay, one last question for this video. This is question number 19, and in this one we talk about integral dx by x power 2008 plus x, and we have to integrate this. Actually, this is a fairly easy question. Again, reinforcing the fact that we should take something common and then try to go for a method of substitution. So what I will do here is I will take x power 2008 common. So this will become x power 2008 and 1 plus x power minus 2007. And there is a dx here, right? Now, if you take 1 plus x power minus 2007 as equal to t, you will get minus 2007 x power minus 2008 is equal to dt, dx. So we have already a dx by x power 2008. So this is x power 2008 minus dx divided by 1 plus x power minus 2007, which will be equal to dt by minus 2007 integral divided by t, right? So this becomes minus 1 by 2007 ln t, and ln t is ln 1 plus x power minus 2007, right? So that will come out as the answer for this. Once you have this, there was an IIT question where you eventually had to find the sum of this. Answer was written in the form 1 by a ln 1 plus b power c, 1 plus x power c, and you have to find out the sum of a and c and stuff. So question is easy, but only if you're able to spot the substitution that is appropriate. And since there are several substitutions that work, therefore actually it is up to you and your creativity to figure out the right substitution for a given particular case. That is why we want to practice as many questions as possible, because by doing questions, what you happens is you get a sort of an intuitive understanding of the subject, and you get a feel for when things are working, when things are not working, and when you should stop trying or keep trying. So these things will become clear in this chapter only after extensive practice. Don't try to memorize too many integrals and mug up too many results. All the results should be proved by you, so that if somebody asks, you should be able to show them what you are able to do, right? So this is question 19, and with that we come to the end of this video. We'll continue with more types of problems. So the next type of problems will be basically questions where there might be multiple correct answers. So far we have been doing questions which are liable to come as a single correct objective. Let's see you next time then. I'll come back with a fresh video on multiple correct answers type of questions, and we'll cover different concepts in integrals there. That's it for now.